Hello, this is a video for chapter 2.4, and today we're going to talk about the partitioned matrices. And we start working with the different types of matrices, and you probably noticed that over a week, the size of our matrices start getting bigger and bigger. And sometimes it's so large that it's kind of cumbersome to work with. So what people usually do, they kind of partition it or slice pieces of our matrices and use them as a sub-matrices. For example, here we have matrix A, and we can slice it horizontally into the 2-part and vertically into the 3-part and come up with like 6 individual matrices. And just to keep a track of position for these sub-matrices, we gave them indices which determine their position within a big matrix. For example, A11, it will be our first submatrix in the top row. A12, second submatrix in the top row. A13 is for a third submatrix for the top row. And we will do the same for the bottom one. And you can see there's a lot of different submatrices here. There is a large one, and there is a smaller one, and there's one which is actually vectors, but we know vectors is one-dimensional matrices, and there's even like the matrix of one element -4, but still this is matrix nevertheless. So the advantage of having these block matrices is that we now can reduce dimension of our analysis. So instead of looking at the 3x7 matrix, we are working with 2x3 partitioned or blocked matrix. And often people use these matrices to kind of in the computer simulation to separate the data. For example, when I'm working with experimental data and I have several experimental conditions, I put those data in the partitioned matrices. So when I conduct the operations or analyze the results, I have a natural separation of my data. Okay, and all mathematical operations for the matrices should work exactly the same for the block matrices. You just want to make sure the dimensions of the block is appropriate. For example, let's take two matrices A and B, and we slice or partition our matrix A into the 4 submatrix, A11, A12, A21, and A22, and our B we just slice horizontally in the 2 parts. So the B now became a vector of consisting of 2 blocks of B1 and B2. So now let's just see how the matrix operations they work. So let's try to find the product of A and B. And to make life a little bit easier for us, I'll introduce some color coding. We will work with the top part of top column to top row of the matrix submatrix A. So I will denote A11 as a light blue and A12 submatrix as a darker blue. And I will do the same with our matrix B. So my top submatrix B1 will be light brown, and my bottom submatrix or block B2 will be a dark brown color. Okay, so now instead of like two large matrices, we have a rather small. So in sub-block notations, our AB matrix will be 2 by 2 matrix A by vector B. And that's in these notations actually searching calculations are pretty straightforward. We will do the basic matrix by vector multiplication. We take a first row of our matrix A, multiply it on the column B, take second row of our matrix A, multiply it by the column B. So we basically write these linear combinations here. Straightforward, but we need to keep in mind that each line here represents a lot of matrix operations. All A's and B's are submatrix. So let's try to calculate everything. So let's start from the first component of our top row, A11 times B1. So, and let's just use our color coding to write our matrices. Okay, that's our matrix A11. And let's just extract our matrix B1. Okay, so only one element already have like two rather large matrix multiplications. And by the way, guys, keep in mind here, we have a proper dimensions for multiplications. We slice it the way that our dimensions are correct. So we have 2 rows in the matrix A11, and we have 2 columns in the matrix B1. We have 3 columns in the matrix A11, and we have an appropriately 3 columns in the matrix B1. Otherwise, we would say that our calculations won't be possible. Our sub-blocking wouldn't be right. Okay, so let's perform the matrix operations and find the result of 2 by 2 matrix. And let's do the same for the second part of our first row, A12, which we multiply by the submatrix B2. And again, we find another 2 by 2 matrix. Now, to find the top element of our product matrix, we have to add those 2 matrices together. So our top row of resulting matrix will be equal A11B1 plus A12B2, which sum of 2 matrices put together. Okay, and that was only the top part of our product, but that's good enough. We can go ahead and write our block or partition into the top of our resulting matrix. And we can perform this similar operation for our bottom row of our product matrix. And this is a little bit simpler computation, so I left it for you to derive, but you can check your result. The resulting submatrix would be 2, 1. Okay, and this is how the partitioning worked. So I'd like you to go ahead and solve several practice problems from the end of the chapter.